The first myth states that an object always moves in the direction of the force exerted on it. Let's test it out. If I exert an applied force on the wall, we can clearly see that the wall is not moving in the direction of the force I exerted upon it. We can use principles of physics to understand why this occurs and how this myth is false. If we take a look at the free body diagram, we can clearly see in the x component that the force of static friction and applied friction are equal to each other. This means my applied force was not able to overcome the static friction of the object. The free body diagram shows that the forces are balanced, and as a result, the object is not moving in the direction of the applied force exerted upon it. The second myth states that an object pushed by a person continues to move with constant speed. Let's put it to the test. If I push this toy car, then according to this myth, it should continue to move at a constant speed. We can clearly see that it did not continue to move with constant speed. We can look at the free body diagram to see why this occurs and how this myth is also false. This free body diagram shows the snapshot of when my hand left the car and the car was still in motion. In the y component, the forces acting upon the object are the normal and gravitational force, which, since they are equal, cancel each other out. In the x component, we have the force of kinetic friction. The system is unbalanced, and as a result, there will be an acceleration on the object. We also see that the force of kinetic friction opposes the direction of motion, so we know the object will be decelerating, so there will be a decrease in velocity over time. As a result, this shows that an object pushed by a person does not continue to move with a constant speed. The final myth states that an object always changes its motion if there is a force exerted on it by another object. Let's put it to the test. We can test this by having this ball exert a force on this shoebox and see if the box changes its motion. From this, we can see after throwing the ball at the box that the box does not change its motion. We can use a free body diagram to see why this statement is false. The box is at rest in the beginning of the experiment because the normal force and gravitational force were balanced. As soon as the ball touched the box, there was an applied force on the box. However, the applied force was not greater than the force of static friction, and as a result, the box did not change its motion and after a force exerted on it by another object, proving that this statement is indeed false.